Good morning everybody. So for our final lesson of year 3 we're going to finish off with some recapping of some previous learning, and then obviously we can move on to some other activities for the day. So I'd first of all like you to have a go at telling me what the shape is in the top corner and thinking is it a 2D or 3D shape. Then to complete the part whole model, thinking about what your numerator is going to be. Number 2, ordering the fractions from the largest to the smallest, thinking about what the rule with if the numerator is 1, the larger the denominator, the smaller the size, because obviously if it was a bar of chocolate, you're sharing it with more people. Equivalent fractions, so you'll have to do see what's happened to the numerator before you can work out what's going to happen to the denominator. And for number 4, complete the sentence. 220 centimetres is something metres and 20 centimetres. Once you've had a go at that, press play and we'll see if you've got your answers correct. So you should have said that the shape was a cube because it's got squares that are all the same size and the same length and got the same angles because it's a 3D shape. Then for number 1, you should have said that it is 5/9 because my denominator stays the same. If I do 7, take away 2, I get 5. Then your answers for number 3 should be 1/3, 1/5, 1/6 and 1/8. Because if we just look at my diagram that I have drawn here, we can see that if we had a bar of chocolate, if we split it into thirds, you would get more chocolate than if you would split it into eighths, because there's going to be more, because if I shade what 1/3 is, 1/5, 1/6, 1/8, you can see that a third you're going to have a bigger piece. Number 3, we want to find an equivalent fraction. So we're going to do, obviously we need to look, we've got our numerators, so I want to know how did I get from 2 to 1? Well, I'm going to divide by 2. How do I get from 8 to my question mark? I'm obviously going to have to divide by 2. 8 divided by 2 is 4. So your answer should be 1/4, 1/4. So looking at the number 4, we want to convert centimetres into metres. Now remember that the conversion is 100 centimetres equals 1 metre. So if I've got 200 centimetres, I'm clearly going to have 2 metres and 20 centimetres remaining. So it's going to be 2 metres in there. Okay, so this time, can you tell me what the shape is in the top corner? Thinking about, it's a bit of a difficult one, this one, but think about what we've already learnt. How many hours are in 3 days? So think about how many hours in 1 day, then how many are in 3 days. Which is a unit fraction? Think about what we call a unit fraction. Why is it a unit fraction? And then number 7, how many thirds are the same as 4/6? So you could either use this to draw it, to see it, or you could do it as an equivalent fraction. And then finally, how many centimetres are there in 1 metre and 45 centimetres? Once you've done that, press play and we'll have a look to see how you've got on. So the shape is a triangular prism. Now the reason why it's a prism and not a pyramid is because it doesn't go to one point at the top, which would be a pyramid, whereas a prism has got obviously the rectangles, and it has also, it's a triangular prism, because it's got triangles at either side. Now, how many hours are in 3 days? So you should know that there are 24 hours in 1 day, so 24 add 24 add 24, or you could have done 3 days, 3 times 24 in each day, which would get you 72. Then finally, your unit fraction will be 1/6. Now the reason why this is a unit fraction is because it has a number 1 as the numerator. The others are non-unit fractions because they don't have 1 as your numerator. For number 7, you could have drawn it and shaded it, or you could have said how many thirds is the same as 4/6. So you could have done it as to find an equivalent. Obviously, we're trying to find the question mark, so we need to know we can get from 6 to 3. We're going to divide by 2, because 3 goes into 6 twice. So I'm going to divide my top number by 2. So your answer should have been 2/3 is the same as 4/6. Finally, number 8, complete 1 metre and 45 centimetres. Well, I know in 1 metre there are 100 centimetres, so your answer should have been 145 centimetres. Okay, so now can you have a go at telling me what the shape is at the top? Then on number 9, what time is it when the minute hand and the hour hand both point to the 12? Now, for an extra point here, you could tell me what it would be as AM and what it would be as PM. Then complete the sentence using less than, greater than, or equal to. So to put it in the middle, if you need to draw it, please do. Number 11, Sally walked 3/5 of a 500 metre journey to school. How many more meters until she got to school? So obviously there's two different ways you could do that. You could find what 3/5 were, and that would be how much she's walked, and then we want to know how much she's still got to walk. So we could take that off 500, or if she's already walked 3/5, we know then she's got 2/5 left to walk, so you could find 2/5 of 500. And finally, number 12, you've got to sort these lengths in ascending order, meaning starting from the smallest and getting bigger because it's going up. So you might need to convert all of these into centimetres first to see which is going to be the smallest. Once you've done that, see how you get on, and then we'll press play and see if you've got them correct. Okay, so you should have counted the number of sides. It's a 2D shape and it has got 1, 2, 3, 4, 5 sides, so it's a pentagon. Then for number 9, if the minute hand is pointing to the 12 and the hour hand is pointing to the 12, we know that when the minute hand is at the top, we would say it is o'clock. And if it's at the hour hand is on the 12th, we would say it is 12 o'clock. Now, if you were to write it as a digital, you could have put 12:00, or it would have been 00:00 if it was in the morning, because remember we add 12 to find the different times, whether it's morning or afternoon, and obviously there's 24 hours in a clock, so in a day, sorry. So it would start a new day on 00. Then you should have said that 2/9 is less than 7/9 because it's got the same denominator and the numerators are different. Because if you were to draw it, it would still have the same number of parts. However, 2 is going to obviously be smaller than 7. For number 11, so it says Sally has walked 3/5, and we want to know how many more meters. So if she's walked 3/5, in order to meet so that she's walked her full amount, we would need to walk 5/5. So she's got 2/5 to still walk, because 3 add 2 would be 5, and that would be her full distance. So we could do 2/5 of 500. Now remember, when we see fractions, we divide. So I'm going to do 500 because that's my total number, and I'm going to divide it by my number of parts, which is 5. So I'm going to draw my 5 circles, 3, 4, 5. Now obviously 500 is a really big number to actually have to dot, so we're not going to dot it fully. We're going to actually think about what we've got here. So we could take off 1 0, or we could take off 2 zeros. If I take off 1 0, how many 5s go into 50? I know that is 10. However, I need to add my 0 back on. So each part is going to be worth 100. So now I know each part is worth 100. I now need to look, how many parts do I want? Well, I want 2 parts. There's 2 lots, and there's 100 in each lot. So I can find out what 2 lots are worth. So my answer would be 200. Well done if you got that right. And it's 200 meters remaining. Finally, we've got 122 centimeters. We've got 1 meter, 20 centimeters. And we've got 2 meters. Now, because these are all in different units of measure, the first thing I'm going to do is I'm going to convert them all into centimeters. So obviously my first one's already in centimeters. My second one, I've got 1 meter, which is 100 centimeters, plus 20, so I've got 120 centimeters, and 2 meters is 200 centimeters. Now I can see that they're all in centimeters, and I can see which one's the smallest. Well, it's going to be 1 meter 20. Then it's going to be 122 centimeters, and then it's going to be 2 meters, because we're going in ascending order, we're going up. Okay, the next one, can you tell me the name of the shape in the top right corner? Then what time is 3¼ hours after 11 a.m? That was quite a challenge. Think about if it's 11 a.m, think about moving your hours first, then moving your quarter hour to say what time it is. And remember, if it's 11 a.m, think about what's going to happen, whether it's going to be a.m. or p.m. 14, which is longer, 2 hours or 700 days. 2 years or 700 days. So thinking about how many days are in a year, so how many would be in 2 years. Then completing the number line, so you're actually filling in the blanks of what there are on the number line, thinking about, first of all, having a guess, so going, right, oh, there's 2/10, I might guess at 3/10 is going to my next one, 4/10, 5/10, oh, it doesn't quite work, so what could I do next? And then for number 16, which lengths can be used to make a total of 60 centimetres? So which numbers could you add together to make 60 centimetres? There might be more than one option, so if there is, for bonus point, you can obviously have a go at telling me the other option. So you should have seen that the shape is a 2D shape, and if you counted the sides, there are 1, 2, 3, 4, 5, 6, 7, 8. So you should have said it is an octagon. Then we've got 11 a.m. and I want to know what 3¼ hours is after. So first of all, I'm going to add 3 hours. So 11, I could keep it in 24 hours, 12, 12, yeah, we could keep it as going after. So 11, 12, obviously we're on a clock. If I just quickly write this, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if it goes from 11, it's going to go 12, 1, 2. And it's going to be, and 1/4 hours, well, if it's going 1/4 hours, we know it's adding 15. So it's going to be 2:15. However, because it was 11 a.m, as soon as it hit that 12, it turns to p.m. So it should be 2:15 p.m. You could have also wrote it in 24 hours, so you could have actually wrote 14:15 to show that it is 2:15 in the afternoon. So either option there would have been fine. Okay, for number 14, we want to know, so in 1 year, there are 365 days. So if they're in two years, I want to do 365, add 365, or I could do 365 times 2. I would know that my answer is 730 days. So we can clearly see that 700 days is going to be shorter and 2 years is going to be longer. For number 15, we needed to complete the number line. Now, if we counted up first of all in 1/10, let's have a look. 0. Well, it starts at 2/10, so even if we went 3/10, 4/10, 5/10, it still wouldn't work. So let's see if we can go up in 2/10. So 0, 2/10, 4/10, 6/10, 8/10, 1. So we know that the answers would be 4/10 and 6/10 to fill in the gaps. And finally, which lengths are used to make a total of 60? So I can have a go. You could have said that we could have had, let's see, so if we could have done 19, add 21. Well, I know number bonds to 10. 9 add 1 is 10, plus another 10, 20, plus another 10, 40. So then if I look what else, I could have also added that extra 20 centimetres, and that would have got me to 60 centimetres. So you could have had 19, 21 and 20 as one option. You could have also had 35, add, let's have a look. Oh, actually, I think that one we can't do, because 35 add 15 would be 50, and there's not 10 centimetres left. Yeah, so that was your option, 19 add 21 add 20 to find 60. First of all, can you tell me now the name of the shape at the top? Then you're writing 8:30 in the afternoon using a 24-hour clock, so there should be 4 digits on your digital clock. If I start school at 8:30 and finish at 3:15, how many hours am I at school? So work out how many hours that has passed, maybe how many minutes as well. Which is larger, 2/3 or 4/6? So you might need to find some equivalent fractions, or you might need to draw it to show it. And finally, number 20, how much shorter is the rubber than the pencil? So you need to work out what the rubber is, what the pencil is, and then what the difference is. Once you've done that, press play and we'll see if you've got them correct. So you should have said that the shape is a sphere because it is a circle, but it is also a 3D circle, like a football. Right, then what we're doing, we're going to write 8:30 in the afternoon. So I'm going to put 8:30 to start with, and because it's in the afternoon, it's going to be PM. Now I want to do it on a 24-hour clock, which means I need 2 numbers before and 2 numbers after on my digital clock. So I know if it's 30, I know 30 minutes has passed, so I can put in my 30, which is nice and easy. However, if it's 8 in the afternoon, we need to add 12 to the 8 because it's in the afternoon, which would be 20:30. So your answer should have been 20:30. The next one, if I start school at 8:30 AM, so 8:30 in the morning, and I'm at school till 3:15 PM, so in the afternoon, how long am I at school for? Well, we could put it on a number line almost, so we could do 8:30, 3:15. We could go how many minutes to the next hour? So it's going to be 30 minutes, and that would take me to 9 o'clock in the morning. Now I could go to my next hour, so I could go all the way up to 3 o'clock in the afternoon. So I could go 9, 10, 11, 12, 13. Oh, I could even change it actually. I could even do it 13, and obviously it's going to be 15. So I could count it that way. I could either go 9, 10, 11, 12, 13, 14, 15, or I could have gone 9, 10, 11, 12, 1, 2, 3. So I know that I'm adding 6 hours. And then to get from 3 o'clock to 3:15, I'm going to add 15 minutes. So you could have either put it into the 24-hour clock to count on, or you could have realised that when we get to 12 o'clock, it then becomes 1. So it goes 12, 1. So if I add all of it together, you should have said that you are in school for 6 hours and 30 add 15 is 45 minutes. So well done if you got that one correct, because that was a tricky one. Which is larger, 2/3 or 4/6? What I would have done here, I would have found an equivalent fraction. So I would have noticed that I've got 3, I've got 6. Well, I know 3 goes into 6, so I could turn my equivalent fraction into a 6. So 3 to 6, I'm timesing my 2, times my top number by 2. Times my top number by 2. 2 times 2 is 4. So it is actually a trick, because it's saying 2/3 is actually the same as 4/6. Because if you were to draw it, if I drew 2/3 and I drew 6, I can see that if I shaded 2/3, it would be the same as 4/6. Finally, the rubber, let's see how big the rubber is. So the rubber from 0 to 6 is 6 centimetres. The pencil, now the pencil doesn't start at 0, it starts at 2 and goes to 11. So 11 take away 2 is 9, so that's 9 centimetres. Now it says we don't want to know how much they both are. It says how much shorter. Well, if one's 6 centimetres, the other one's 9. If we did 9, take away 6, your answer should be 3 centimetres. Okay, so for the next ones, tell me the name of the shape at the top. Then how many hours and minutes are there between 9:15 and 11:45? So put it on a number line and work it out that way. Then what time does it show on the clock? So there you can tell me as an AM and PM on 24 hours as well. Complete the missing. What do you add to 5 twelfths to get to 1 whole? And finally, one side of the hexagon is 5 centimetres, so what is the perimeter of the hexagon? Looking at this regular hexagon, all the sides are going to be the same, so how are you going to work it out? Once you've had a go at doing that, press play and we'll see if you've got them correct. So you should have said that the shape is a circle because it is a 2D shape. Then for 21, we want to know how many minutes and hours there are between 9:15 and 11:45 in the morning. So if I drew my new number line, I could go up to my next hour, which would be 9:15 would become 10. If there are 60 minutes in an hour, 15, take that off 60, you would have 45 minutes. Just going to put 45 mins. Then I'm going up to my next hour, which is 11. So I'm adding 1 hour. And then finally, I want to get from 11 to 11:45. So again, I'm adding 45 minutes. Now I need to add them all together. So I've got 1 hour, but then I've got 45 at 45. Well, 5 at 5 is 10. Add 40 is 50. Add 40 is 90 minutes. But 90 minutes, if we put that into hours, remember there are 60 minutes in an hour, so I've got one lot of 60. How many remaining? Well, I've got 60 up to 90 is 30 minutes. So now, if I then add my extra hour that you have here at the top, you should have had 2 hours and 30 minutes. So 2 hours and 30 minutes was your answer. Okay, looking at the time on the clock, if we look at the minute hand, each little line represents 1, so we can see that it is 3 minutes, and we know it's past because it's on the past side. 3 minutes past, and we can see that it's gone past the 6, so it's 3 minutes past 6. Now, if you're writing it in digital, and a clock is 24 hours, obviously we know it's 3 minutes past, so we need to put 03, not 30, because obviously that would be 30 minutes past. And if it's past 6, we need a 0 for the morning in front of the 6, and for the afternoon we add 12, so 6 add 12 is 18:03. For number 23, we needed to work out the missing number sentence. Now, if I first of all, I look at my whole is going to have a denominator of 12 because my other two numbers have a denominator of 12. And if it's a whole, it means the top number's got to be the same as the bottom number. The numerator and the denominator are the same. So 12 twelfths. So now what do I add to 5 to get to 12? Well, I could take it away. 12, 11, 10, 9, 8, 7. So you should have said 7 twelfths. You add to 5 twelfths to get 12 twelfths or 1 whole. Finally, we've got a hexagon and it says one side is set 5 centimetres. Now a hexagon, a regular one, all the sides would be the same length. So I know every single side would be 5 centimetres long. So I could either add them all up, 5 and 5 and 5 and 5 and 5 and 5 and 5, or I know there are 6 sides, so I could do 6 times by 5 centimetres because it's 5 centimetres a side. If I do my 5 times table, 5, 10, 15, 20, 25, 30, I know that the perimeter is 30 centimetres. First of all, can you tell me what the shape is at the top? Count the sides really carefully. Then you'll tell me how many seconds in 3.5 minutes. So think how many seconds are in 1 minute, so how many are in 3.5. Then which of these is the same as 4:30 p.m. So have a look really carefully to see which one is right. If you find which one is right, maybe you could think of why are the other ones wrong, what is wrong about them. Then number 27, which month is closest to December, May or September? So you might have to count up in your months to see which month is closest. And finally, which of the following are unit fractions? So writing down which ones are the unit fractions. Okay, so the shape at the top, if we count, is a 2D shape, and let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a 10-sided shape is called a decagon. Well done if you got that one right. Okay, I want to know how many seconds are in 3.5 minutes. Well, in 1 minute, I know that there are 60 seconds. So in 3 minutes, I want to do 3 lots of 60. Take off your 0, 3 times 6 first of all, 3, 6, 9, 12, 15, 18, and then put on your 0 on the end. And I want to know what half a minute is. So if I know 1 minute is 60, I want a half of 60. Let's take off my 0. Half of 6 is 3. Put my 0 on is 30. So I now want to do, I can get rid of my conversion at the top. I want to do 180, add 30, which will have got you the answer 210 minutes. Looking at number 26 then, I want 4:30 in the afternoon. Well, all of the numbers have got 30 minutes past, which is perfect. However, if it's in the afternoon, it is not going to have a 0 before it, because that would mean it would be in the morning. It would add 12 to the 4. So if we do 12, add 4 would be 16, 30. That one is the one that is correct. Now 14, even though it's got a 4 in it, that one would be wrong, because 14:30, if you take off 12, you would have 2, so this time it actually says 2:30 in the afternoon. Which is the closest month? Well, if I write mine down quickly. So I've wrote down all of my months of the year. Now if I'm starting from December, I want to see which is closest. So if I go to September, if I go to May, December, so we've got January, February, March, April, May. So I've got 1, 2, 3, 4, 5 to get to May. If I'm at December, I can go backwards till I get to September. What? November, October, September is only 3, so you should have said that September is closest. Finally, which one are the unit fractions? So unit fractions just mean that the numerator is 1, so you should have got 1/12 and 1/3. All the other ones are non-unit fractions because their numerator is more than 1. Finally, our last set of questions. What is the shape at the top? Then saying a TV programme starts is 90 minutes long. It starts at 11:15 AM. What time does it finish? So put it on a number line. Start at 11:15, move it 90 minutes, what's going to happen. And then using the less than, greater than or equal to sign, can you say, is 200 seconds greater than, less than or equal to 3 minutes? Here I would suggest converting 3 minutes into seconds, and then you'll be able to see it. Which is longer, 2 days, 50 hours or 100 minutes? So again, convert them all so that they are, so that you can work it out. Then what is 1/10 smaller than 1 whole? So think about what the whole would be. If you take off a 1/10, what would it be? Press play as soon as you've done that, and we'll see if you've got the answers correct. So the shape is a 2D shape. It has got 6 sides. We would say it is a hexagon. Well done if you got that one correct. Okay, a TV programme. It starts at 11:15 AM, and we know it lasts 90 minutes. But we don't know what time it finishes at, so we're going to work it out. Now I know in 1 hour there are 60 minutes, so I know it's going to go over an hour. So what I could do is I could go, and I could even add an hour on. So I could either go to my next hour, or I could add 1 hour, because I know 1 hour is also the same as 60 minutes. So my minutes aren't going to change, but my hour is going to change. Now I'm going to add an hour on, but it would then become 12:15. So now we've gone from AM, and now we're going to be in PM, because it's hit the 12, so it's going to change to PM. Now if I've used an hour, which is 60 minutes, I know I want to add 90 minutes. So the difference between 60 and 90 is 30. So I now want to add 30 minutes on. So I know that looking at that, I know 30, add 15, 30 add 10 is 40, add your 5 is 45. It's not gone into my next hour, so my hour is going to stay the same, 12:45 PM. And obviously if we were writing that in 24 hours, we wouldn't need the PM, it would just be 12:45. Okay, so in 1 minute, we know that there are 60 seconds. So in 2 minutes, there are 120 seconds. So in 3 minutes, there are going to be 180 seconds. So I can now see that 200 seconds is going to be greater than 3 minutes because 3 minutes is 180 seconds. Okay, which is longer? So 2 days, we know in 2 days there are there's 24 hours in a day. So in 2 days, it's going to be 48 hours. We've then got 50 hours. And then we've got 100 minutes. Now, I've got two where I've got hours and I've got one with minutes. So I need to convert my minutes into hours because I've already got hours here and hours here, because we need to find something that all of them can convert into. So I know in 1 minute, in an hour, there are 24, in 1 hour, there are 60 minutes. So if I've got 100 minutes, I'm only going to have 1 hour, because there are 60 minutes in an hour, and I would have 40 minutes left over. So now, if I have a look, I can clearly see that the longest amount of time is going to be 50 hours, because 2 days is 48 hours and 100 minutes is only 1 hour and 40 minutes. So just because 100 is the biggest number, it doesn't mean that it is the biggest amount, because it's actually minutes compared to hours or days. Finally, we want to know what 1/10 is smaller than a whole. Now, if I look at my denominator, I know my denominator is 10, so if it's a whole, my denominator still has to be 10, but my numerator would also be 10, because that is my whole, because my numerator and my denominator are the same. So if I find one less, one smaller, so I'm doing 10/10, take away 1/10, your denominator will stay the same, and 10 take away 1 is 9/10. Well done if you've got those. That was a really tricky one, a really good challenge for you to finish off our maths for year 3. So absolutely brilliant work. You've worked so hard this year, especially over the last few months. Keep up your times tables, keep up practicing lots over your time, your money, fractions, things like that over the holidays, just to keep it nice and fresh. And obviously then we can move on and develop this in September.